Hi guys, I'm going to go over Chapter 16, Section 5, which is the autoionization of water and pH. And these notes are going to be handwritten, so you guys can handwrite them if you choose to. Writing them down is going to help you remember them. So I would do that if I was you. Autoionization of H2O and pH. So we're going to cover both things. So the autoionization of water just says that when we have water, there are a bunch of these little H2O molecules floating around. So remember, it looks like a little Mickey Mouse. I have oxygen, and hydrogen, 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 hydrogen. When these bump into each other, a reaction can happen, and it does. Only a very small fraction of them will do this, but some of them will actually transfer a hydrogen from one water to the other. So if I take this hydrogen and I move it over to the other one, what I get as a product, this is an equilibrium because it's a reversible reaction, I would get H3O plus as this little hydrogen moves over and attaches itself there. I would get H3O plus, and I should have put this is liquid, and this would be aqueous. And the other one is now missing an ear. It's just an OH by itself, OH minus, also aqueous. And that is the autoionization of water. It's water ionizing all on its own without us adding any acid or base to it. Okay, so that can happen. This is a reversible reaction. So we have yet another K. Okay, and if I was writing out the equilibrium constant for this reaction up here, the products on top would be H3O plus, 3O plus, and OH minus, and it would be divided by my reactant. However, some of you guys probably noticed these are both pure liquids. The L afterwards means that those do not go into my equilibrium constant expression. Okay, so there is no denominator for this equilibrium expression. And because this is a very special equilibrium constant, again, just like we did with the acids, we're going to get rid of the C, and we're actually going to call this Kw for the ionization constant of water. And fun fact, you're going to have to memorize this number. It's always the same value because it's water. We do have to specify the temperature, but you don't have to worry about this. They will always use this value. So if you change the temperature, it can change the K value. You don't have to worry about it. This is the only number you have to memorize. 1.0 times 10 to the negative 14th. So if you multiply the H3O plus times the OH minus, you get this value. If these two things are equal, which they are in pure water, you're going to have a 1 to 1 to 1 to 1 ratio. Mole ratio is always 1 to 1. So to find the concentration of these, if it's neutral, that means you haven't added anything else. If it's neutral, then H3O plus equals OH minus, and it would be the square root of my Kw. It's like calling this X times X, and if you solve for it, you would take the square root. The square root of this guy is 1 times 10 to the negative 7th. So that's a neutral water sample. I'm getting way ahead of myself, but I'm going to do it anyways. What is the pH of neutral water? 7. How do we find that? pH is the negative log of H plus or H3O plus. Okay, and so the negative log of this, the negative log of 1.0 times 10 to the negative 7th, you're saying the negative version of the exponent of 10, that's 7. Okay, and if you don't believe me, we can do that. Yeah, that's what I thought. Okay, so this is going to be, I have to enter 1.0 exponent negative 7. So you put in some calculators, you have to put the value in first. If you hit log and it says error, it's trying to take the log of 0. So put in your number first if you have that type of calculator. If you have a fancy calculator like a graphing calculator, you're going to put negative log, parentheses, enter the number, in parentheses, hit enter. Okay, the log of that guy is negative 7, and it's the negative log. So my answer is the negative log of 1 times 10 to the negative 7, positive 7. And that's where the pH comes from, of neutral water. That's why it's 7. Okay, now in your book, I want to show you this equation. It's down here. This is the auto ionization of water that I wrote. This is the Kw value. Here's the lazy version. So you can put H plus times OH minus. And because remember, H plus and H3O plus are the same thing. They are one and the same number. They are one and the same thing. Anytime you have H plus, it's going to turn into H3O plus. And here is that value that I said we're going to have to memorize. It's right here. Kw is 1 times 10 to the negative 14th. Okay, and look, they solved for the concentration of neutral water. In a basic solution, that means that the concentration of OH is going to be greater than the concentration of H plus. So we need to do some problems where we actually solve. Okay, so we're going to use the this equation. Let me rewrite it so it's not quite as messy. Kw is 1 times 10 to the negative 14th, and that's equal to the H, let's put the lazy version, H plus times OH minus. If I know Kw, which I do, it's always the same number, and I know the H plus, I can calculate OH minus using simple algebra. The exponents are ugly, but solving it is just basic algebra. So an example in your book is, look at when H3O plus is 7.5 times 10 to the negative 5th. H3O plus, 7.5 times 10 to the negative 5th. What is OH minus? Okay, we're going to plug it in and solve. Kw, that's 1.0 times 10 to the negative 14th, equals H3O plus, so I'm going to plug this number in, times 10 to the negative 5th, times my OH minus. I don't really need that parentheses there. I'm going with it though. So to solve for OH, divide by 7.5 times 10 to the negative 5th on both sides. This side will cancel out. OH minus is, grab my calculator here, 1 exponent negative 14. Whoops, nope. Delete, I'm back to clear, sorry. 1 exponent, this is the negative sign, I put minus negative 14. Okay, so that's my Kw. I'm dividing it by, divided by 7.5 exponent negative 5 equals 1.3333. So we'll do, there's two sig figs, 1.3 times 10 to the negative 10th. 1.3 times 10 to the negative 10th. So that's how you solve these. So it's an algebra equation where you have two possible values, they give you one, and you use algebra to solve the other one. Let's see if they got that in the book. That was A. Yes, they did. So see, they're using this equation to set it up. They plug in the 7.5 times 10 to the negative fifth for H3O plus, and then they solve for OH minus by dividing, and that's what they got. Okay, and because the H concentration, 10 to the negative fifth, is greater than the OH, 10 to the negative 10th, it's an acidic solution. So that's what they're telling us there. You guys can try the other two examples on your own. So plug in this 1 times 10 to the negative 7th and solve for OH. Plug in the 1.5 times 10 to the negative 9th, solve for OH, and see what you guys get. Okay, so I've already previewed pH. pH is a way for us to make the number a little easier because these 10 to the negative 10th powers and 10 to the negative 14th powers are kind of ugly. If we take the negative log of them, we get numbers between 0 and 14 usually for normal solutions. You can have negative pHs, but we don't usually. It's usually between 0 and 14 or even 1 and 14. And let's write that equation down one more time. pH equals the negative log of H plus. That's the lazy way of writing it. The negative log of H3O plus. It's the proper way that your book will have for finding pH. And for these pH problems, literally all you do is you plug in the H or H3O plus into your calculator, you take the negative log of that, and you have your pH. Okay, so let's see if they have some examples. A solution with H3O plus equal to 1 times 10 to the negative third has a pH of, and then you just do the negative log of that concentration, and the answer for that one is 3. What we need to know as well is the pH scale. On the pH scale, it usually goes from 1 to 14, 7 being neutral. Okay, and anything less than 7 is acidic. Anything higher than 7 is basic. Another word for basic is alkaline. It's the same thing. That's just an older term. Alkaline means basic. And this means on the left, you have a high concentration of H plus, and on this side, you have a high concentration of OH minus. Okay, so that's the pH scale. So when we just found a pH of 3 right here, this pH equals to 3, I can tell you that it's going to be an acid because it's on the left. Okay, it's smaller than 7, so it's acidic. Okay, oh, and it summarizes it right here. If you'd like to add those to your notes, you can. Less than 7 is acidic, greater than 7 is basic, and equal to 7 is neutral. And look at that, they plug this one in. This is a neutral compound. Excuse me. This is kind of weird. When you take the log of the number, so for the 1.0 times 10 to the negative 3, for example, that had 2 significant figures in the given value. You need 2 decimal places in your pH. That will never come up on the AP test, so if that makes no sense, don't worry about it. But just know if you want to be proper, the number of sig figs is how many decimal places in your pH you want. Okay, oh, there's the pH scale. And calculate the pH of a solution, indicate whether it's acidic or basic. So to find the pH of A, I'm just going to take the negative log of that guy. So I'm going to put the number in first in my calculator. Clear, that would be 1.8, exponent, negative 4, and I'm going to take the log. This is not the natural log, by the way. This is not ln. This is the log base 10, meaning 10 to what exponent equals this number. So log, and then don't forget it's the negative log. So 3.7 for A, And since that's less than 7, it's going to be acidic. So let's see if they got 3 point. If I wanted to be proper, it would be 3.74, and that's acidic. 3.74, and it's acidic. We did that correct. For the OH, oh, that's a fun one. If they give you the hydroxide concentration and they ask you for the pH, there's 2 ways to do it. I'm going to do the long way first. Sorry. OH is 1.3 times 10 to the negative 2. Let's do that over here. Okay, OH equals 1.3 times 10, was it negative 2? Yes. Okay, so that's the given, and they're asking you what is the pH. Now, for pH, you have to plug in H+, but I have this equation. Remember this guy that we just learned? So I'm going to plug in 1 times 10 to the negative 14th. I'm going to plug in my OH here and solve for H+. So that goes there. Times H3O plus equals 1 times 10 to the negative 14th. Divide both sides by 1.3 times 10 to the negative second times 10 to the negative second, and H3O plus equals, excuse me, negative 14th divided by 1.3 exponent negative 2, and that is 7.69 times 10 to the negative 13th. 7.69 times 10 to the negative 13th. And then pH is going to be the negative log of H3O plus. So plug this value in here. And I can do that very easily if I hit log and then negative. It's 12. There's 2 sig figs, so 12.11. And since that's greater than 7, this is going to be basic or alkaline. And let's check our answer. Yes. So see, they used the KW equation to solve for H+. They plugged H+ into the equation and they got 12.11, which makes it basic. You can try these for practice problems if you want to try them out yourself. They're exactly like these up here, so you can check your answers in the back of the book and see if you did it correctly. Okay, and I'm going to go over this, calculating H3O plus from pH. So we're working backwards. Calculate H3O plus for a pH of 4.80. So our given for this problem, given is that pH equals 4.80. Our unknown is what is the H3O plus. Okay, and I'm going to use the equation for pH. pH is the negative log of H3O plus. Okay, and I know pH, it's 4.80. Did I copy that correctly? Yes, 4.80. So I plug that in for pH. It's the negative log of my unknown. Okay, so now how do you get H3O plus by itself? In algebra, if we had 2x, we would divide by 2. We're doing the opposite. So if I'm multiplying it, I'm going to divide to solve for x. We are taking the logarithm of this. So we have to do the opposite of logarithm, which is on your calculator. If you find the log button above it, it will say 10 to the x. The opposite of logarithm is raising it to 10 to some exponent. So I skipped a step as well. We have to multiply both sides by -1 because I want positive. So multiply both sides by -1 to get rid of that negative in front of the log. And then we need to get rid of the log. 10 to the negative 4.8. 10 to the, this is like, it's also like if you square root, square they cancel out. Same thing, 10 and log cancel out. So I've just solved for H3O plus, and it's going to be right here, 10 to the x. So I'm going to do 10. Oh, it just did 0. I got to put the exponent in. 4.8 negative, and take 10 to that power. 1.58 1.58 times 10 to the negative fifth. 1.58 times 10 to the negative fifth. And let's see what your book has. Yes, that was only 2 sig figs, so I should have rounded it to 1.6 times 10 to the fifth. So that's how you undo the pH. That's how you undo the logarithm. And this sounds like another thing. It's really not. Instead of pH, if you want the POH, you plug in hydroxide instead of hydronium, and it's the exact same math. So you would just plug in the OH. Down here, this is a handy dandy version of the equation. pH plus POH equals 14. Let's put that into our notes. Okay. pH plus POH equals 14. So the easy problems will tell you POH is 2. What is the pH? It has to be 14 minus 2, which is 12. You just plug in the one that's given, and you solve for the other one. If we had this knowledge before, and remember it wanted us to find pH, so it told me the OH concentration. The OH concentration was 1.3 times 10 to the negative 2. If OH is 1.3 times 10 to the negative 2, and I find the POH by taking the negative log of that OH, I'm going to do clear 1.3 exponent negative 2 and take the negative log of that. It's 1.89. So if I find the POH, pH is just going to be 14 minus 1.89, which is 12.11. That's my pH. If I go back, when we did it the long way, I got 12.11. So either way will work. I prefer to find the POH and use this instead of plugging it into the KW value. Either way, you get the right answer. So it's up to you guys. Okay, conceptual connection. As pH of a solution increases, if the pH is getting higher, what happens to the acidity? Well, a higher pH means it's more basic, so that means the acidity goes down. So the correct answer would be the acidity decreases. That's special about ulcers, and that is it. Okay, we will go over this tomorrow, and I will see you guys later. Have a great day. Bye-bye.